Hi everyone. Let us discuss Cloud Computing Unit 2. Topic 7. Virtualization. 2 mark questions. Define virtualization in cloud computing. Name one type of virtualization. Give one example of a Type 1 hypervisor. Mention one container technology used in cloud computing. State one difference between a VM and a container. 5 10-mark questions. Explain the concept of virtualization and its importance in cloud computing. Describe the types of virtualization with examples. Discuss hypervisors and their role in virtualization. Compare virtual machines and containers with advantages and use cases. Explain how containers like Docker and Kubernetes enhance cloud application deployment. Introduction. Virtualization is a fundamental technology that powers cloud computing, allowing multiple virtual machines or computing resources to operate simultaneously on a single physical system. It works by abstracting hardware from software, creating a virtual environment where applications and operating systems run independently of the underlying hardware. This leads to efficient resource utilization, flexibility, and scalability, as physical resources like CPU, memory, and storage can be shared across several virtual instances. For example, a single physical server in a data center can host multiple virtual servers, each functioning as an independent system. Virtualization serves as the foundation for infrastructure as a service, IaaS, platform as a service, PaaS, and container-based deployments in modern cloud platforms. 1. Definition and importance. Virtualization refers to the process of creating virtual versions of computing resources, such as servers, storage devices, networks, or operating systems, instead of relying on physical hardware for each resource. Virtualization allows multiple virtual environments to run on a single physical system. In the context of cloud computing, virtualization plays a vital role by enabling efficient resource utilization, scalability, and isolation between workloads. It allows organizations to deploy applications faster, manage workloads dynamically, and recover quickly from system failures. By maximizing hardware efficiency and providing flexible resource allocation, virtualization forms the backbone of cloud infrastructure and service delivery. Analogy: virtualization is like having multiple apartments on the same floor of a building. Each tenant enjoys complete privacy and independence, even though they share the same structure. 2. Types of virtualization. Virtualization can be categorized into several types, based on how the underlying hardware and operating systems are abstracted. The major types include full virtualization, paravirtualization, and OS-level virtualization. Full virtualization provides a complete abstraction of the underlying hardware using a software layer known as a hypervisor. In this type, the guest operating systems and applications run unmodified, as if they were operating directly on physical hardware. This ensures full isolation and compatibility between multiple virtual machines. Example: VMware XC is a well-known platform that provides full virtualization. Paravirtualization differs from full virtualization in that the guest operating system is aware that it is running in a virtualized environment. The OS is modified to interact efficiently with the hypervisor, resulting in improved performance due to reduced overhead. However, it requires OS-level modifications, which can limit flexibility. Example: Xen Hypervisor supports paravirtualization. OS-level virtualization operates at the operating system layer, where multiple isolated containers share the same OS kernel, but run as independent environments. This approach is lightweight and efficient, making it ideal for microservices and cloud-native applications. Examples: Docker and LXC, Linux containers, are popular OS-level virtualization technologies. 3. Hypervisors. A hypervisor is a software layer that enables multiple virtual machines, VMs, to run concurrently on a single physical host, effectively abstracting hardware resources such as CPU, memory, and storage. Hypervisors are classified into 2 main types: Type 1 bare metal and Type 2 hosted. Type 1 hypervisors run directly on the physical hardware without requiring a host operating system. They are commonly used in enterprise data centers due to their high performance, efficiency, and strong isolation between virtual machines. Examples: VMware ESXi, Microsoft Hyper-V. Type 2 hypervisors, on the other hand, run on top of an existing host operating system, which makes them easier to install and use on desktops or for testing environments. However, they may incur additional overhead compared to Type 1 hypervisors. Examples: Oracle VirtualBox, VMware Workstation. Hypervisors are the backbone of virtualization, enabling cloud providers to deliver scalable, flexible, and isolated computing environments for multiple users on shared physical infrastructure. 4. Containers. Containers are lightweight, portable units designed to run applications along with all their dependencies, while sharing the host operating system kernel. Unlike virtual machines, containers do not require a full guest OS for each instance, which makes them highly efficient and fast to deploy. Popular container technologies include Docker, which provides a runtime environment for building, packaging, and running containers, and Kubernetes, which is an orchestration platform for deploying, scaling, and managing containers across clusters of machines. The main advantages of containers are faster deployment compared to VMs, lower resource consumption, and easy portability across different environments, ensuring consistency from development to production. Analogy: containers are like packed lunchboxes. You carry only what you need, and it works anywhere without additional setup. Please have a look at VM versus container comparison.